Hi everyone, welcome back to the workshop, and in this video I'm going to do a repair and a TFT conversion on my HP3478A multimeter. This one's a little bit sick, so we need to do a little bit of a repair first. We've got a problem with some of the buttons on the front not working, so we'll repair that first and then we'll look and see if we can do a quick TFT conversion of this unit here, because it shares the same protocol as far as I'm aware, and actually the mounting of the LCD is identical, so we should be able to just make a slight adjustment to the code and drop the TFT right in. There we go, one screw holds the top cover on. Taking a look inside, you can see the rear of the LCD there is identical to the 3457A, including the removable ribbon cable connection down onto the motherboard there. And I'll bring up on screen the schematic for the display interface, and you can see we've got some of the same signal names that we had with the 3457A. But first things first, I want to try and get that keyboard fixed. Some of the keys are not working at all, so we'll remove the front panel and try and get access. Well, as you can see, I've had to strip the 3478A quite far down in order to get at the front panel. Now, one thing I've noticed, there is actually two different variants of the 3478A. This one's got an aluminium chassis, and I believe there's another one with a steel chassis and a slightly different front panel configuration. And I think the steel one is actually a good bit easier to get into. And not to mention, as I said, I wanted to remove the display board. However, it's going to be a little bit of a challenge on this aluminium chassis one, because the front panel board isn't screwed onto the front panel like the steel version is. This one's not got any screws. You can see the front panel plastic, it's just been melted onto the back of the PCB in order to hold it in place. So that's going to present a little bit of a challenge for me to remove the board in order to fix a couple of those front panel buttons. I think the front of the PCB just needs cleaned up, or the button itself has lost a little bit of its conductive pad on the bottom, but I can fix that either way. But the real mission for this 3478A is to do a TFT conversion on it. And as you can see, I'm just doing a little bit of a trial fit on a spare 3457A board, and there is one problem, and that is the board actually needs to go that way around onto the back of the display panel. But as you can see, this header here, this ribbon cable, not long enough. Now this is a schematic for the 3478A, and over here we've got that ribbon cable connector here. And looking at the signals, we've got O2, PWO, sync, ISA, IWA, which I'm taking as INA. And those signals there map exactly onto my display board, so the pinout is exactly the same. And here we have R506, 1K resistor, series resistor, and the 5V supply to the 5 volts going off the display. So just like the 3457A, I'm going to have to bypass that resistor as well. Now, one problem that I've got is that this ribbon cable here with its header isn't long enough to go right across to this end over here, based on the board from the 3457A. So I think I'm going to have to respin a board and move that header into the middle there, so it can plug in round about there. So I'll go off and redesign this board, and then I'll come back. And here's my mock-up of the PCB, moved the header, and perfect. Plenty of room, a little bit of slack in the cable, no problem at all. So whilst I'm waiting on the PCB arriving, I do need to look at the front panel push buttons. So there's the front panel, and it's got quite an interesting PCB on the back. If you compare it to the steel chassis 3478A, this being the alloy one, the PCB is quite a bit different. It's a lot smaller on the other 3478A and a lot easier to take apart as well. It's just screwed in. And there's a couple of other interesting things on this front panel. Number one, this is the calibration switch, which is accessible on the front panel there. There's a sticker over the front of it. And basically you just rotate that round and you can see the mechanical nature of the switch. Totally bespoke by HP by the looks of it. It will rotate round and connect up those two pads at either side there and make the connection. And then the front panel membrane for all the push buttons on the front mate up to the motherboard in the main unit via this here. The PCB's got fingers on them, edge connector fingers, and they just sit on here and make contact and down onto the PCB. Now, like I said, this panel here is not so easy to get apart, and on the steel version these are screws, but yeah, looks like we're going to have to melt some plastic or shave off those tops there to get it apart. But I've got no choice because, as I didn't show at the very beginning, the problem with this front panel is I think these 4 switches here are not working. But before I do that, I think I'll just double check. I'll clean up this with some IPA. I'll clean up the fingers on the edge connector on the main PCB and just assemble this again and just see if it actually fixes the problem, just in case it's an issue here rather than here. Okay, I've cleaned it up with some IPA, so I'll just go test out a couple of the buttons here. So I'm on VDC at the moment. Yep, VAC, 2 wire ohms, 4 wire ohms. DC current's not working. AC current's not working. Shift's not working. Yeah, and some of the other ones are working, so yes, definitely around this end by the looks of it. And just to show you one of these studs, there's the top of it there, and if you look just in there, you can see it there. That plastic shaft that comes up through the PCB and then just melted on the top side. And before I can lever it up, I will need to remove this switch as well. There we go. And I think that's it. Well, let's try a spludger. Let's see if I can get it raised up. It's coming away at this end. Oh, it's coming away at that end, but it's just being held down here, so I suspect it's the studs here, the plastic studs there are melted onto the plastic carrier for this here, and that's what's stopping it. So wow, that's tight. I might need to melt them to release it. So I'm going to try a sacrificial soldering iron tip. That's it, that's that one. But this one is being a bit harder. That's it. There it is, and you can see how these contacts here mate up to here and then the fingers in the PCB mate up to this other side. So yeah, it all looks perfect on this side. Nice gold plated PCB. So let's try and lift it off. There we go. Well, this isn't good. Look at this here. I can't lift the PCB off because of this here. And this cap here for the fuse is plastic welded onto this part here. So I can't really get that off, and I don't want to force it in case I break it. However, I do have enough room in there. Remove the membrane there, clean it up, and also clean up the PCB there, and hopefully render a repair. So I'll lift out the membrane. There it is. And you can see the remains of the studs there, which I'll have to do something about in order to secure the PCB back on. But first things first, let's check out the membrane. Let's make sure it's okay. So the problem push buttons are at this end here. So let's just check out this end, because I know these ones here were working. Let's just go onto this pad here with my ohmmeter. Both probes onto the pad without letting the probes touch together. Just across the pad we should be getting a resistance. It won't be 0 ohms. They're conductive pads, but they're not exactly 0. And you look at that, 45 ohms. And just try another 2 points. Yeah, 50 ohms, something like that. So let's go along them all. Yep. 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 And the shift one was definitely a problem one. It seems okay. Right along the top side. So far so good. Looks like the pads are okay, but I'll give them a clean up with just some light IPA just in case. Clean up the pads with some IPA. Now interestingly, these 6 pads here are all linked together. It looks like we've got a group of 8 here and a group of 6 here. So I wonder if the problem is to do with this group of 6. It all looks okay there, but I will clean up the PCB. If I just zoom in on these pads here, not sure if you can see it, but you can see the markings on them where that black plastic carrier for the conductive strip there was making contact. And this one here, for some reason, does look a little bit tarnished compared to the other ones. So I'll give these a clean up as well. And a final wipe down. And on the inside as well. There we go. Let's see if I can squeeze it back together. There we go. That's looking good. And I'll give this a clean up as well. The actual conductive strip just comes off, and that'll give me a chance to remove this glue here, ready for it to be put back on. And as for this here, I think I'll just clean this up with IPA. But one thing I have noticed with it is it's arc shaped, if you can see that there. This is a flat bottom here, which mates up with the flat bottom in here, but it's not exactly uniform all the way along it. If you look along it, not sure if you can see that, but there's flat spots all the way along it, and I think that's where it contacts with the PCBs, both of them, the one in the front panel and of course the one in the main unit. So I wonder if this is deformed slightly and it's not getting a good contact down onto the PCB. So I think maybe the way to fix that is if I put some light pressure on the top, will that make the sides of it push out a little bit? Not sure. So let's just try it here. Very, very lightly. Well, it is a little bit. So I think what I can do is just very lightly just go along it and just push it down a little bit. Not much. And we'll try that. But first of all, I need to give it a clean up with some IPA as well. And you can see how it works. It's just like a zebra strip really. You've got some metal tracks that just go from this side right around to the other side there, and they're all independent. But it's kind of like a zebra strip that works at two different angles at the same time. I'm thinking about it, I'm not too worried about the studs round the PCB here, but I'm concerned about these two here, because this really needs to have a good fixing. So I wonder if there's something else I can use to hold this down onto the PCB. Well, I wonder if I can make use of these M2 plastic screws. They've got extremely flat heads on them, and if I put them on the underside of the PCB, I think there's enough room if I clear the remains of the plastic stud. Well, I'll give that a bash. So I've cleaved the remains of the studs there. So let's just put the screws through and just temporarily put a nut on them. And let's see if that's going to work. Just about, but not quite. Well, actually, I think I've had another idea. The head of that screw is sitting on here. So if I remove some of that rubber so that the screw can actually sit down into a little cavity there, that'll fix the problem once and for all. Right, not sure if this is going to work. I've got a hole punch here, and a little bit of wood there just between. I'm not sure if this will work, but we'll give it a bash. No, it's just rebounding off of it. Hole punch is not sharp enough. Oh, but wait a minute, it did. Look at that. Yep, I think I'll give it another go. I will need to clean up this membrane again. Put the membrane back in again. It'd help if it was the right way up. There we go. And put the screws back in again. And just place it back down. Make sure the heads of those screws sit in the rubber, which they are. That should be a lot better. I think that'll do it. Yeah, buttons feel a lot better now. So let's assemble it onto the motherboard now, and let's see if it actually works. Right, that's it powered up. Now I haven't sorted out the fixing of the PCB onto the front panel, but I've assembled it enough just to be able to test it. So let's just go along, have a look. Yes! Shift button's working. AC current, yes! DC current, yes! That one won't work at the moment. Yes! S trigger's working. Shift address. Yes, HP address. Yep, the buttons are working. So I'll call that a fix. So now I just need to get the PCB attached properly to the front panel. So how am I going to fix back those studs there? 1, 2, 3, 4, 5 of them. Well, I think what I'm going to do is I'm going to use my sacrificial tip on my soldering iron and melt it and try and introduce some new plastic at the same time. I'm going to try and do this left-handed so that you can see it at the same time. So I've got some PLA here from a 3D printer. So let's just try that. Not easy left-handed. That might actually work. I think I'll call that a win. It's not pretty, but it's functional. And there it is, refitted for the final time, hopefully. Right, the next thing is the new PCB for the TFT display. The only thing I need to do before I do that is I just need to bypass that resistor for the 5V supply as I mentioned earlier. So I'll do that now, and there it is, R506 linked out. Okay, and here's the 3478A with my development kit for the TFT upgrade all hooked up. I've written the software, I've managed to convert my original 3457A code for the 3478A, just a few modifications required, including one of the I/O lines down onto the main board. The clock signal, I had to use a different clock signal because the one that was used for the 3457A wasn't suitable. But it's up and running now, and I'm just about ready to take off the development kit and put the new board into the back of the display there. But I'll just power it up as it sits on the workbench here. We've got the TFT hooked up so you can see it running. And there it goes, mimicking the LCD on the 3478A perfectly. Now I have made one or two small modifications like I did with the 3457A, and the first one is the original LCD doesn't support lowercase, exactly the same as the 3457A, but I've managed to convert that in my software and I get millivolts displaying properly instead of the uppercase M. And some of the other problems that I came across was the fact that the original LCD doesn't distinguish between an S, the letter S, and a 5. It just uses the same symbol, and it kind of works on the original LCD because the S is a little bit of a cross between the 5 on the original LCD. However, when my code sniffs that data, it was displaying S where a 5 should go, so 134.S0S on the display there. So I've had to put in some extra code in order to sort all that out. The other thing I've done is the flashing decimal point at the far right hand side on the original display it indicates a trigger or a sample, and I've managed to make that a little bit bolder, and I've coloured it green there so it flashes away a little bit more obvious. And here is the new board, well, my prototype anyway, which I'm going to fit to this unit here. One tiny little mod that I had to make on the back of the PCB, and that was just using a different clock signal driving the STM32. I had to use 01 clock and not 02 clock. And that sorted that out, and I will make the gerbers for the final board in the video description down below. So I've got the TFT driver board mounted, I've got the STM32 all programmed up with exactly the same code as on the development board, and it's just a case of fitting it now to the back of the 3478A. So let's go ahead and do that now. And also I've 3D printed a mount to make it a little bit easier to attach the board and the TFT onto the back of the display. So first things first, let's get the wires that I'd hooked up for my development board removed. And the next thing is just to remove the original LCD, which I'd already unscrewed, and it's just a case of unplugging this from the back of the original display. There we go. And then plugging into the new board. Now this display board here needs to be orientated that way. You've got pin 1 at that corner down there, and it just goes in like that here. I'll just plug it in and give you another look. And there it is, the ribbon cable coming off over the top of the TFT driver board. You see pin 1 down at that corner there. And next, the 3D printed mount for the TFT. Well, I've got the TFT here, I've pulled off the protective cover on the front of it, and you've got a cavity at this end here. There's no cavity at that end there, and that's to accommodate this flat flex. So just drop it in there, it'll sit nicely in the bottom there, a little bit of leeway, and you can see the flat flex there. Then next we need to hold the TFT down into the 3D printed mount. And the way I'm doing that is with a couple of biscuits. Now if you're a woodworker you'll know what I'm talking about. And there's a couple of holes on either side there and down in there to accommodate the biscuits. So it's just a case of clipping them into place like that there. And the other one. And that's it. Now unlike the 3457A, the transparent screen in there is not removable. That's fine, we're going to leave it in anyway. So it's just a case of taking the new TFT and dropping it in to the cavity there. And then when we attach the new board, it'll hold it all in place. Now I'll just go away and do that off camera. It's just a case of fitting a couple of screws, but I need to get my head right over it to do that. And there we go, you can see it fitted, screws are tight. Only thing I've got to do is to plug in the flat flex at the end there, do that in a second. But just to note also, there's that R506 resistor down there, that's bypass there for the 5V supply for the display board. And there's plenty of room in and around the STM32, and everything else doesn't seem to interfere with anything. So let's plug in the TFT and let's arrange for a power up. So there's a little wee latch which you need to raise in order to allow it to accommodate the flat flex. And once it's in, just put the flat back down again. There we go. Right, we're ready for a power up, so let me just lean over and turn on the power. Yes, it's working! And the first thing I notice, the digits are nicely aligned, and same with the annunciators in the window, because I was prepared to move it up and down a little bit just to compensate for the bezel and the window and everything, but actually it's looking not too bad. And just like the 3457A, I've chosen white and green, including for the flashing indicator there, meaning it's triggering, it's sampling. And if I just go through the modes, let's try 2 wire, yep, 2 ohm, and 4 wire ohm, milliamp DC current mode, milliamp AC, and the buttons here should be working. Yep, shift buttons working, and the HPIB address 16. So let me hook up a PDVS2 Mini and let's just try a couple of different voltages. And spot on 1 volt. Now of course it's only a 5-digit multimeter. I'll try the 4-digit mode. Yep, and the 3-digit mode. Yep, everything's working. And I don't think it looks too bad. And of course we've got test and reset. Yep, all digits on. I don't think the symbol or whatever it was that came up originally on the original LCD was available to me, so I just chose the hash, and of course it illuminates all the annunciators there. And the nice thing is, I might have mentioned it earlier, got a nice big sampling indicator there rather than that tiny little decimal point that was hidden in the corner. So I'm trying to make this as big as possible without interfering with the annunciator digits right next to it. You've got to be careful when you're writing to these TFT LCDs. If you get too close to another digit, a lot of funny flashing happens. It's not a completely seamless draw over the top of something else, and it'll just draw over. It won't do that. It causes all sorts of weird things, rolling over digits and all sorts of things, but it seems to work okay. And there it is, all boxed up and running. And I notice I'm missing a fuse holder there. I have to see if I can find one of them. And I've had to 3D print a couple of switch caps there because they were missing as well. But other than that, it seems to be working and it looks to be fairly accurate. Could probably do with a little bit of a recalibration, but that's for another day. The only thing I'd possibly like to do is maybe incorporate a metal plate behind the board to try and shield it from the analog stuff. On the 3457A, I got away with it because the analog board is in a compartment all of its own and quite well shielded. But in this much smaller 3478A, it could probably do with a little bit of shielding. On the other hand, it's only a 5.5-digit multimeter, so I don't really think it's going to suffer that much. So let's get it up onto the shelf, and I'm going to do some long-term testing, leave it switched on permanently, as we are drawing a little bit more power from the power supply with that 5 volts required for the LCD and STM32, etc. But it shouldn't be a lot of current, so I don't think there'll be a problem. And there it is up on the shelf, and I think it'll do just fine up there, no problem at all. So there we go, we've got 3 TFT conversions now, 3478A, 3457A, and of course my very first one, the R6581T. The only one out of the 4 I would really like to do a TFT conversion on is the 3245A, and that's one for the future. At the moment the VFD is still quite bright, but I think it would transform this as well if it had a lovely coloured TFT on it. But of course that's a different story, reverse engineering the 3245A, because it doesn't have the same signals as the 3457A and the 3478A. So anyway, thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.